Now we will look at parts B and part C. So what we need to do is find the values of x such that f of x equals 1, and then we also need to find the points on the graph where f of x will equal 1. So for part B, we're going to replace f of x in the equation with the number 1. So I get 1 equals 2x minus 6 over x squared minus 8x plus 15. Now, I'm going to write 1 as 1 over 1, and the reason why I did that is because now I have one fraction equals another fraction, or one rational expression is equal to another rational expression. This allows me to treat my equation as a proportion, and I'm able to set the cross products equal to each other. So I will take the denominator of the fraction on the left and multiply it by the numerator of the fraction on the right, and then I will do the same thing with the numerator of the fraction on the left, which is just 1, and multiply it by the denominator of the fraction on the right, which is x squared minus 8x plus 15. So on the left side, I'm just distributing 1, so I get 2x minus 6 equals x squared minus 8x plus 15. I have a quadratic equation because I see the x squared, so in order to solve this, I need to set the equation equal to 0. Okay, so I'm going to subtract 2x from both sides, and I'm going to line the 2x up under its like term. So when I subtract 2x, I'm subtracting it from negative 8x, and then I'm going to add 6 to both sides, and I'm going to add 6 to the constant 15. So I line everything up under their like terms. Now, on the left side, 2x minus 2x is 0, and negative 6 plus 6 is also 0. So I'm left with 0 equals x squared minus 10x plus 21. So I have to factor. So 0 equals x minus 7 and x minus 3. So if I set each of these binomials equal to 0, I will get two solutions. So if I set x minus 7 equal to 0, I get x equals 7. And if I set x minus 3 equal to 0, I get x equals 3. But now, remember what we found for the domain in part 1. We found that there were two excluded values for x. The two excluded values were 3 and 5. So I have to throw out the solution x equals 3. Okay, let's take a closer look at that. My denominator is x squared minus 8x plus 15. If I were to substitute the x in the denominator with 3, I would get 3 squared minus 8 times 3 plus 15. That would be 9 minus 24 plus 15, which would be 0. So I cannot keep the solution x equals 3 because that would cause my denominator to be 0. X equals 3 is not part of the domain. So my answer here is just x equals 7. So the value of x such that f of x equals 1 is 7. Because if I were to plug in x equals 3, I would get an undefined expression. All right, now we can answer part C. So if f of x equals 1 when x equals 7, that tells me that f of 7 equals 1. So the input is 7 when the output is 1. So the ordered pair on the graph that gives me an output value of 1 is 7, 1.